So in this question, we have a wind that is striking on the surface of the building and brought to rest. And we want to know what is the average force of the wind on the building. And again, because this is a question that involves force, we want to use the momentum form of the Newton's second law. So this is equation 7.2 of section 1. Okay, and there is no change in the mass, but it's brought to rest. That means there is a change of velocity. So the change of momentum will come from the change of velocity. So it's m delta v over delta t. Okay, so delta v, we already know it's 120 kilogram per hour. And what we really need to know now is what is m over delta t. So this can be done by looking at what is numbers that we're given. We're given the air has a mass of 1.3 kilogram per cubic meter. That is the density rho. So we can say mass equals delta t. We can try to write mass as rho times v over delta t. So v is the volume. So we also have a building. We have its width and its height. So that gives us the surface area of it. So we can further decompose v into the surface area times the distance it goes through. So what is this? This is how much distance this air has to go through in a certain amount of time in order to have certain volume. So in other words, this is a distance that is traveled by the air in a certain amount of time. So when we put L and the delta t in the denominator together, this becomes rho times A times V. And V is the speed of air. It's the same as this 120 kilogram per hour. So really what it's saying is that because this air is moving with the initial speed of 120 kilogram per hour, that means in 1 second a volume of air, the air is brought to rest with the volume of the surface area of the building times the 120 kilogram per hour. So that is what is giving us the amount of mass that is brought to rest per second. So let's try plug everything in and see what we get. If m delta t is this, we have this equals rho times A, delta f equals rho times A times V times delta V, which is also the same V. And okay, so let us try to figure out what is V in SI unit, because right now we have a kilometer per hour, which is different from which is different from the SI unit we want, because we want meters per second. So rho is 1.3 kilogram per cubic meter. Surface area is width times height, 45 meters. Velocity is 120 kilogram per hour, and we can do it by 100 kilogram per hour times 1 meter per second over 3.6 kilometer per hour. That's just a conversion factor. So delta V is V initial minus V final. Here V final is 0 because it's brought to rest. So it's equals to V initial, which is the same as V. So we can just, this whole thing, we can just give it a square cube. Yeah, so if we just plug in this whole thing into the calculator, say all in SI units now, we will get a number of 4.9 times 10 to the 6 kilogram meters per second squared. So this is the same unit as Newton. So that is the average force of the wind on the building.